Hello students, we're going to do an activity together today. You're going to work through the activity as you listen to the instructions that I give you as we go. So we're going to start out by reading about the cotton candy grape, and you can follow along on the screen here. So horticulturalist David Kane and his team at International Fruit Genetics in Bakersfield, California, made the cotton candy grape by hybridizing two different grape species. So the designer fruit is actually a hybrid, like pluots, that's plums and apricots, peacherines, peaches and nectarines, and cherubs. I have no idea what that is. Might be good. I don't know. We already have other varieties that taste like strawberry, pineapple, or mango, he says. We're still testing out to see if those are commercially viable. And he's talking about grapes there. Weighing in at about 18 grams of sugar per 100 grams of grapes, the designer fruit isn't cloyingly sweet. It has about 12% more sugar than regular table grapes, but far less than raisins, which have more than 3 times the carbs. Almost all of the table grapes in America belong to the species Vitis vinifera. There's nothing wrong with that. Vitis vinifera is a noble grape. It is used to make all of our wines. But the world has dozens of grape species, and restricting the fruit in grocery stores to just one species also limits their flavors, Kane says. Take, for instance, the Concord grape. It's used to make Welch's juices, jams, and jellies. The dark purple berry is packed with exotic flavors and aromas, including one known as foxy. But the Concord grape has seeds, and its skin tends to fall off. Not great qualities for a table grape. So Kane decided to put all the flavors of a Concord-like grape into the firm, crisp, and seedless Vitis vinifera by crossing the two species. He couldn't say exactly which Concord-like grape he used because it's a trade secret. The whole process takes at least 6 years and sometimes up to 15 years, Kane says, but he thinks it's worth it. A lot of fruit becomes tasteless by the time somebody buys it, Kane said. We want to change that. What I would like you to do now is to watch the YouTube video called Farmers Grow Grapes That Taste Like Cotton Candy for some more background information on the genetics of cotton candy. You can find this link in either the online version of this document that I'm using or just linked in today's assignment in Google Classroom. When you have finished watching this video, then come back and join us again. Okay, now that you've watched the video, let's go ahead and talk about what you need to do here on your paper. And so unless you're watching this for quarantine or for an extended absence, you will be doing this on pencil and paper. So the first thing here, David Kane and his team used good old-fashioned plant breeding to develop the cotton candy grape. While he won't say exactly which Concord grapes were used in the final combination, here is an example pedigree of the crosses that were used. So Muscat, Hamburg, and Carver produced the Concord. Villard Blanc and Elmer Swenson produced the California. And the Concord and the California produced the cotton candy grape. So on this pedigree, please circle the parents of the cotton candy grape and the grandparents of the cotton candy grape. Now that you have circled the parents and grandparents of the cotton candy grape, let's go on to take a look at the genetics. So in grape genetics, sweet is dominant, and here's the genotype for Muscat Hamburg and for Carver. Go ahead and just write those in on your paper, maybe above or beside each of the names. Sturdy skin is recessive. Villard Blanc's genotype is homozygous recessive. Elmer Swenson's genotype is heterozygous. Write those in as well. Seeds are dominant. Cotton candy's genotype is homozygous recessive. And Concord's genotype is heterozygous. And finally, the last thing to write in is that purple color is recessive. So Concord's genotype is homozygous recessive, and California's genotype is heterozygous. So you're going to take that information and you're going to do some Punnett square work on the next page. So let's move on to the next page. So this is the cotton candy grape. You can find this pretty frequently in grocery stores around here. It is seedless, it is green, and it is very, very sweet. It also has a sturdy skin that doesn't peel off very easily. So you are given 4 squares down here, and you are going to use those squares as the space where you will work out how um, the cotton candy grapes got their genotypes. So if you remember back to the bell ringer that we did on Monday, we were working backward. And so you'll have to do some working backward because there are some of the grapes up here in this family tree. There are some grapes up here that you're not going to have the information for. So use what you have. Use the basic technique of working backward from the Punnett square. Use what you know about um, recessive and dominant traits, and see what you can do to model how the cotton candy grape got its sweet flavor, its sturdy skin, its green color, and its seedless appearance. If you need extra space, then you can just write extra on a sheet of paper. Make sure that you label very clearly what your models are if you're using an extra sheet of paper. So I want you to pause and work on this and then come back when you're done. Okay, now that you have finished all of your models here in this part, I would like you to think about a hypothetical situation. And so what I would like you to think about is the information that we learned in watching the Amoeba Sisters. As you watch the Amoeba Sisters video on sexual and asexual reproduction, you learned quite a bit about how asexual reproduction results in offspring that do not have genetic diversity. They don't have genetic variation. So what I would like for you to do, and you can use maybe this part down here. Well, okay, so I would like you to go ahead and use this bottom part here. Um, it says breeding seedless grapes isn't easy because they can't reproduce on their own. After fertilizing the plant, Kane and his team have to take out the baby embryos from the plant, then grow them in individual test tubes in the lab before they ever make it to the field. Kane painstakingly created about 100,000 of these test tube plants before he stumbled upon the cotton candy flavored grapes. Even though the plants don't breed on their own because it requires crossing 2 plants, this is still considered sexual reproduction. So you have pollen from one plant and you have the ovum from another plant, and so you get the fertilization by the gametes and you get the zygote produced and you get a new creation there, a new organism that is a combination of genetics from 2 separate plants. So that would be sexual reproduction. However, if the growers eventually decided that they had the perfect grape and didn't want to risk changing any of its genes, how could they produce these grapes and guarantee they would get the same taste and look every single time? Illustrate your answer below. So the basic idea here is that you're going to work through asexual reproduction. So we're going to have kind of a cause here, and that cause is going to be asexual reproduction. So what type of asexual reproduction might you use? And think back to the activity that you did, the worksheet that you did. Think back to the videos that you watched for the Amoeba Sisters and even revisit those if you need to. Then consider, what would you do? What would you do in order to produce these perfect grapes every time? You may want to show how the genetics work for this. That would be a really good idea. You've got some materials to use for Monday because you made a drawing of what mitosis or the basics of asexual reproduction looks like. So you may want to take a look at that information. May, as in hint, hint. You probably want to go back and look at the stuff. And so show how you could produce the exact same grape over again, not using sexual reproduction, this time using asexual reproduction. Then down at the bottom, to summarize all of this, write one sentence describing the relationship between the parent and offspring if the grapes are bred in this manner that you illustrated above. This should probably all take you most of class, so if you're done really fast, you probably want to go back and check your work. I'll see you guys on Wednesday. Have a lovely day.